Now, what we will do is we will look at the internals of the graphical method. So how is graphical method able to identify the maximum or minimum value of the objective function for us? So let's interpret the solution. The given objective function in this case is that maximize the value of z, which is given by z is equal to x plus y. Clearly, the slope of this function is -1. And for simplicity, what I'm going to do is I'm going to assume that z takes a value of 25. So once you do that, you will see that by plotting the lines 25 is equal to x plus y or x plus y is equal to 25, we will observe a line which will be similar to this dark black line. And this line is called as objective function line. As a next step, I'm going to increment the value of z to a higher value. This is what will happen. The slope still will be the same. However, the line will move to a higher value of x and y. Maybe something like this, depending on what is the new incremented value of z. So this process can be repeated slowly, and the objective function line will move towards outwards. In this current scenario, we will see that it is moving towards the point of maxima and something like this. So clearly we see that by incrementally changing the value of z, our objective function line is able to identify the maximum value for the objective function. You may also want to notice that the maximum point is the corner point feasible solution, which we did talk about in the previous slides also. So now let's change the problem a little bit. So earlier we were told by the management that let's maximize the value of the production, which was, in our case, let's just maximize X tons of bony type and Y tons of chewy type. But now we are given more details. We are told that, the bony type gives us a profit of $300 per ton and chewy type gives us a profit of $100 per ton. The management wants us, in this case, to maximize the profit. So our objective function will translate to z is equal to 300x plus 100y. X is the amount of bony type produced and y is the amount of chewy type produced. So z is equal to 300x plus 100y. What we will notice immediately is that the objective function line transforms to something what you see on this slide, because the slope becomes slope equals -3. What we will find is that now our maximum point is point number 3, where x should be 45.6 tons and y should be 5 tons. Logically also it makes sense that we are making more profit on type X, so we should produce the most of type X, and 5 tons is the minimum. Remember, we have a minimum that we have to produce of Y, so we will produce the minimum. Now let's look at another scenario. So this is where we flip. We say, the profit on actually bony is $100 per ton and on chewy is $300 per ton. So our z transforms to 100x plus 300y. Slope is -1/3, and in this case the objective function line finds the corner point feasible solution as point number 1. Again, logically, if we look at it, it makes sense that type Y gives us more profit, so we should be making more of Y, and again X is the minimum amount that we have to. What we observe is that in this case, the point of interest, which is maximizing z, depends on the slope of the objective function line. If we have a slope which is what you're seeing right now, the point of maximum will be 1, it could be 2, it could be 3, and it could be any of these 1, 2, and 3 depending on what is the objective function slope and what is the objective function. You may also want to notice that in a scenario where your objective function line is parallel to any of the constraint, you will have at least two and at the same time infinite number of solutions. Let's say this line was parallel to our constraint number 1, which is 50x per 24y. In that case, this line will be overlapping our red line and intersecting point 2 and 3 at the maximum point. So of course 2 and 3 are two possible solutions, but every point on this line is a possible solution. So that's where it is possible to have multiple optimal solutions, and which are infinite number of them, because there are infinite number of points on a given line.